Today we continue our look at developments. We have done developing prisms and cylinders, and today we turn our attention to developing a pyramid. You should recall that a pyramid will have a geometric shape at its base: square, triangle, pentagon, hexagon, one of those shapes, and the sides will be triangular in shape, giving you the elevation with that triangular shape. We have on the page set out here a plan and a front view of a square pyramid that has been cut off at the top. That cut off shape is usually referenced as a frustum, but to show you how we got to this shape, I will just drop in the construction lines just to give you an idea of how we built up the shape. So these are the construction lines in place. We need to keep these construction lines knocking around because we will be using for other things as well. But this, you're given this shape and you're asked to produce the development. Before we can get to the development, however, we have to look at what the plan, the complete plan would look like. And along the way for producing the plan, we'll also have to produce an elevation. So it's regular orthographic projection. Let's see how we can proceed. I'll be dropping in some lines using different colors. We know that these lines would still be construction lines, but I'm just dropping them in different colors for clarity. So to plot what the cutoff shape would look like in the plan, we would have to drop these 2 points down to the plan. We would need 4 points since it is square. However, in dropping the vertical center line, we can't plot points on that line, so we would need to produce the end view to allow us to plot those points. So we'll do that process in another line as well, and we know the process for producing the end view. 45-degree angle coming down this way, then you'd be looking at 135. So you pull your 45-degree, and then you would be pulling the lines just as you would for any regular orthographic drawing. I'm taking the heights across first. So I'm taking each line, each point on the front view across the page. If this were manually being done, it would be pulling these lines using your T-square. And now we're going to go to the plan and pull these lines to intersect. This is the center line. So the center line is going to go all the way up to the top, while the other two corners will stop short to give us the base. We are then in a position where we can complete that triangular shape, but we know that the end result would not really be the triangle, since we would have to be plotting then the shape of the cut surface in there as well. For our purpose though, we want to get back to the plan. So now that we have plotted the center line going on to the end view, we can then proceed to pull that line back on to the plan. So we go back to the lines that we were using before for plotting that component, and we bring these now down to 45 and back on to the vertical center line of the plan, and that will allow us to show the points that we'll need in the plan view. Now you can then connect these lines to give you the shape of the cut surface looking down on the plan. You would see a kite-like, rhombus-like shape representing the surface in the plan. So let's go now and put in the lines for that. So this represents that shape, and because we have corners for the square pyramid, we would also have to highlight these lines. To allow us to complete the plan. Now if I took off some of the extra lines, you would better be able to see what the plan looks like now with the correct lines in position. This gives you a better, clearer idea of what the plan looks like with everything in position. You could proceed to complete the end view, but that's not for us at this point in time of critical importance. So we will leave out the further construction of the end view, but just note that a square could be produced over here. In fact, let me just put in that bit of the drawing for you so that you will understand as well. A square could have been plotted here on the end view, and because it is in first angle projection, that square would that shape would actually have formed hidden detail. But I just dropped it in there so that you could see what the shape would look like, and I'm gonna take it out so that we don't further confuse the issue. So we have the front view and we have the plan now drawn as they are supposed to be shown. So now we're at the stage where we can seek to produce the development. One thing we will need to be sure of is the length of a side in the plan. So let's just make a check, and that is 42 millimeters. So we keep that in mind as we continue with the construction. Now, there are a number of curves that will have to be represented in order for us to do this development. I'm going to carry some lines across all at the same time just to allow us to pull those curves. The first curve, and I'll change the line so that again we represent this part of the drawing in a different line as well. So we want to pull a curve. We can use center start length. So this is the center, this is the start, and we can have that curve coming around like this, and that's your base curve. We will need to produce another 3 curves because the slope will give us curves for the development shape as well. In order to pull these curves, we're gonna have to bring the points on the sloping surface across to the side of the elevation, across to the side of the triangle, and the curves will pick up from on the side of the triangle. So we will need to just get a line coming here like that, and then we will also need to get a line coming here for your construction. Now you can go back to pulling the curve. So we're using the same method. So we now have another curve in position, and again we go back and we're pulling our third curve. And then we need one more curve. So we're now pulling the fourth curve. So we have this series of curves going around for your development. Now it is a pyramid, therefore the sides are straight. So even though we've pulled curves, we have to make sure that we have straight sides. So we remember that we said the length of a side was 42 millimeters. So now what we want to do is to mark off arcs going around the circumference of the big curve equal to that 45 radius. So we'll pick our center point. We know that we want the curve to be radius 42. So we put in 42, we hit enter, and then we pull our curve like so. So that gives you your first curve on the construction. And then you can continue. Let me just change the color just to make sure that we're seeing these in a different color as well, just for clarity. So that's the first of those curves in, and I'll just continue with that color for the curves. Then you know your radius, so you know the curve that you're using. You will plot your second curve again, radius of curve 42, enter 42, and that gives you your second arc, and you continue with this process. So we can now go to plot for our third arc. And now we need to put in that fourth arc. Sometimes these arcs get a little tricky as well. So we're pulling that fourth arc in now. So now you have marked off the four sides, the length of four sides of the pyramid as represented on the plan. So you have those in. You can proceed then to draw in those lines as well. So it is just then a matter of putting in these lines to show you the base of the construction. You could as well complete the construction, well, this phase of the construction, by pulling lines to the apex of the triangle. So let's drop in those lines in a different color. So each one of these points will be pulled to the apex of your front view. And that would be the four triangular sides now being represented. So in order to complete this construction, we would then have to plot the points as the circles are representing to give us the shape for the top piece for this slope. We would have to be plotting that to give us that shape. So I'm going to plot that in a blue line because that's going to be one of the finished lines. So I'm going to plot that with a blue line. And it's just a matter then of moving through the points of intersection. It's as though it's been plotted for you already. Once you're able to follow the steps, you will have no problem. And then we can proceed from here to outline the figure, because we know now that the base will also be an outline. So we would have just proceeded then to outline the figure here, and you know, because of the shape, that the lines, the corners must be folded So this is the stretch out distance, the stretch out shape. We know that the lines must be folded. So at this stage, we can drop in our hidden detail lines now to represent the folding lines for us. And this is the development for the square pyramid. I'll take off the number of these lines that we use. Remember, we just use those lines for clarity. So I'll just now take off some of those lines just to clear up and show you exactly what the final product would look like. And I'll just take off that the set of construction lines as well. So this then would be a representation of the development for the frustum of this square based pyramid. The development doesn't have to start exactly on the side of the front view. You can join a line a little away from that, coming from the apex as well, and then you can proceed to step off the distances that you want. Sometimes if you're cramped for space, you may do the development in a completely different area of the drawing sheet if you're doing a manual drawing. However, you should try as best as possible to be able to pull the lines, the curves, and the lines accurately to give you the final product. As usual, it is orthographic projection, so the view should be labeled front view, plan, development. And if you have to do it manually or you have to do it using CAD, you should understand the process, because it is the process that becomes important. It is the process that will allow you to complete the construction. We will now move to another little example. This is for a hexagonal pyramid. I will just talk you through this construction just to show you the difference, and also to stress one important feature with regards to developing pyramids, and this is sometimes where you will be required to plot a true length. You should remember true lengths as a topic, a standalone topic, but it is applied in other drawings as well, in other areas. So imagine that you were sitting at your window and you were looking at the side of your neighbor's house. So you could see the sloping roof, but if I asked you to tell me the length of the roofing material, permaclad, galvanized, whatever, you wouldn't be able to accurately tell me that length because you're seeing a slope. In order for you to be able to tell me that length, you would have to position yourself, or pick up a viewing point at right angles to the roofing material, at right angles to the permaclad, to actually tell me the length of that permaclad. The same thing applies for these constructions. So as we go through, this will probably become clearer to you. Now, we have represented then a frustum of a hexagonal pyramid, and if we drop in the construction lines for you to see, we've gone through that process on the previous drawing, so I'm not going to spend a lot of time with that, but we need to produce the end view. So the construction lines that are represented here are pulling the view over to the side so that you get the end view in position. Once I've done that, pull those lines, then you can see me plotting now what would be coming off of the slope. So I'm pulling lines down onto their corresponding lines in the plan, and I've also had to pull the center line across to the end view and back onto the plan to give me the extra points that I would need on the vertical center line. So this should sound a little bit familiar. Now, if I show you what it looks like then with those parts of the drawing completed, then you would see the hexagonal shape representing the cutoff piece in the plan, and you also get to see the hexagonal shape representing the cutoff piece in the end view. This hexagonal shape over here would be in hidden detail, but for clarity I've left it as a solid line so that you can see it a little more clearly on the screen. So this is what you would be representing if you started out to do this drawing This is the three views that you would be representing on the page. Now, we're on to the development now. Remember, the development is going to come off of the front view. However, if you look carefully, you will see that none of these corners fall on the horizontal center line. If we check the previous construction, we had two corners falling on the horizontal center line. This meant we didn't have to find a true length for the length of side, because once a corner was on that horizontal, that automatically became a true length. So because we do not have any of these corners falling on the horizontal, what we will have to do is to swing one of the corners to that horizontal position and then transfer that point of contact up to the front view. I'll just drop in those lines for you now so that you can see. If you look carefully, and I'll just make it a little bigger to give you the opportunity to see as well. If you look carefully, there's a purple curve. So you've gone from the center, and this curve would have been plotted coming around here. This purple curve represented. And if you continue to look, then you will see then that where that has touched the center line, I've carried a vertical line up to the base of the front view. Having gotten that line to the base of the front view, I am now able to draw what we can call the true length of a side for this drawing. So this line now represents that true length. Once we have the true length in place, it is that true length line that will be used as our base for doing the development. So I can show you the curve, because the steps now basically remain the same as what we did on the previous construction. So just bring it down a little bit so we can see the entire page. I can show you the curve in position. I can show you the arcs that are representing then the 6 sides of the hexagon, and we know that we also would have needed to bring across the points of intersection between the slope and the sides of the front view. So those have come across, not to the side now, but across to the true length, to allow you then to pull the curves that you need to pull. So if I drop in, those are the curves now. You see those curves coming around, and we know the rest of this construction. Certainly we have those curves coming around. Then our next step should be to pull the lines into the apex, and once we've pulled those lines into the apex, then it is quite easy for us to put in our outline, and then the next stage will be to make sure that we have our hidden detail, our folding lines in position as well. So this is just an example for producing a pyramid, the development for a pyramid. I chose to do this one because it contains more details, and the first example that we looked at would have been relatively simple with the square pyramid, but I just wanted to show you another pyramid, another construction, that you would see that the method remained the same. Even though the complexity of the drawing may have changed, the method, the steps to be followed basically remain the same, and that is what is critical for us to note and remember, that the process, the steps will always be the same. If I pull off some of these lines, I'll just give you the opportunity to see the construction a little more clearly. So we take off as many of these extras as we can so that you can see the final product, showing you front view plan and end view. Remember, we would have had the hidden detail over this side and the triangle would have been in place, and then the development, which is what we're really concerned with, the development of the frustum as we were required to produce. Again, labeling becomes important, so you will label your views front view, plan, end view if you are required to draw the end view, and you will label the development. Practice will help you to get a little bit better with these constructions, and remember the knowledge of this process. It is critical. You remember that you'll be tested in the multiple choice exam as well on constructions such as these, so you have to make sure that you understand the process. You have to make sure you understand the reason for the steps that you'll be required to take in a construction, because then it will position you to better be able to answer any questions that come in an exam. Remember that these constructions can be done manually or they can be done using CAD, but the steps and the process should be the same. The solution should be the same no matter the method that is used for the construction. Thank you for paying attention. Thank you for your time. And as usual, I look forward to bringing you another lesson in the not too distant future.